Section 1.3, partial fractions. So in the previous sections, you were adding or subtracting two algebraic fractions. You could have more than two, and getting an overall combined algebraic fraction as the result. Now here in this section, in the next few sections, we're going to do the reverse of that process. So we're going to split a fraction like the one here into partial fractions, and this is a very common method that will help you then with binomial expansion questions or with integration, commonly used. So over here you need to think, what were the fractions that were added together, combined together to give me this overall fraction? As you can see, there's two factors in the denominator, so that means we'll have two fractions. So it's a over x minus 3, since we don't know how many of these, plus b over x plus 1. Now, because there's a quadratic in the denominator and the linear expression in the numerator, we are going to rewrite it as a constant over x minus 3 and a constant over x plus 1. And this is quite a common thing with this topic, that we'll have a constant over number. Right, so now there's two ways of doing those questions. One way of doing it is by substitution, one way by equating coefficients. But before you can appreciate both methods, what you need to do, you need to manipulate the right hand side so you get the equivalent expression. So one way of manipulating these is actually to add these two fractions together. So the one on the right hand side will have a common denominator of x minus 3 and x plus 1. So you'll have to multiply the first fraction by x plus 1 and the second fraction by x minus 3. The key thing here is not to multiply things out. So what do I get? I will get a times x plus 1 plus b times x minus 3 over x minus 3 multiplied by x plus 1. And this is equivalent to the fraction on the left hand side. So notice the denominators are the same. So that means you can compare or equate the numerators. So it's 6x minus 2 must be equal to a times x plus 1 plus b multiplied by x minus 3. Another way of obtaining this result is imagine now you are allowed to get rid of the fractions in this expression. So you are going to multiply this side by this denominator. So you will be left with, so moving it across and multiplying this one by x minus 3 and x plus 1. So x minus 3 would have cancelled and you'll be left with x plus 1. And if you multiply this by x minus 3 and x plus 1, x plus 1 would cancel and you'll be left with x minus 3. Now here's the two methods. So the first method we're going to use is substitution. So substitution. So all you need to do, you do not expand these at all. What you're going to do, you are going to substitute the values of x that will make each of those brackets disappear. So first one, if you make that equal to 0, x plus 1, 0, you'll get minus 1. So we're going to substitute minus 1 into the left-hand side and the right-hand side of our equivalent expressions, numerators. So on the left-hand side goes 6 times minus 1 and then minus 2. On the right-hand side, you've got a. I'll put it down here, but I knew that would be equal to 0 because that's how I chose this, so that I could get rid of a, plus b, and then it's minus 1, minus 3. So that clearly will go to 0. And then you've got 6 times, you can put it into the calculator, so you don't really risk any, making any mistakes. Minus 8, and this is minus 4b. That gives me b is equal to 2. So I've already found b. Now the second value you're going to pick is the one that makes the second bracket equal to 0. So x minus 3. So this one is from x plus 1 equal to 0, and this one is from x minus 3 equal to 0. So that will work for using 3. The reason we do it so you can have a quicker way of finding the answers for A and B, because you will make effectively 0 of one letter plus a combination of the other letter. So this one here, 6 times 3 minus 2 is equal to A times 3 plus 1 plus B, and then 3 minus 3. So again, this time B will go to 0, and you will have 4A, and then 18 minus 2, which is 16, giving me A is equal to 4. So what's my answer? You're going to have 4 over x minus 3 plus 2 over x plus 1. So that is our fraction split into partial fractions. Now, how do you do by equating coefficients? So you get to the same stage over here. Now this time you can expand it. Okay, so you will have 6x minus 2 on that side, and you will have ax plus a, and then bx minus 3b. And we're going to equate coefficients of x. Okay, so what is with x's on the left hand side? You've got 6. What is with the x's on the right hand side? Well, on the right hand side I've got a lots of x's and b lots of x's, so it's a plus b. Then I'm going to equate the constant term. So this is really constant, which is x to the power of 0 if you think about it. So you've got minus 2 lots on the left hand side. They need to be equal to each other for those two expressions to be worth the same. And you've got a minus 3b. There you go. So you've got two equations and you solve simultaneously. So you could just subtract if you want to. So you have 6 take away negative 2. How you can substitute whichever method you want to do. A minus a will cancel. B take away negative 3b is 4b. That gives me b is equal to 2. And a, we need to think from this, a must be equal to 6 minus b. So 6 minus 2, which is 4. So a is 4. Most of the time, this top method is preferable. Most students prefer that. Okay. So now sometimes you have a fraction with more than 2 factors in the denominator. You can just split it into 3 fractions. So you could put a over x, b over x minus 1, and c over 2x plus 1. And let's imagine multiplying through by this denominator or bringing these into the common denominator. I don't mind how you want to think of that. So if you imagine multiplying through, you need to have a multiplied by whatever it's missing. So the x's will cancel, so it will be multiplied by x minus 1 and 2x plus 1. B will have to be multiplied by whatever b is lacking, so x and then 2x plus 1. And c needs to be multiplied by the remaining 2, x and x minus 1. And that is, since you're multiplying through, you'll have just the numerator left on that side. Okay, so I am going to use the method of substitution. So I'm going to make each of those equal to 0. So if I make x minus 1 equal to 0, That means I'm going to put x equals 1 into the whole expression. Looks horrible, but don't forget that when you put x equals 1 into this, that will go to 0. When you put x equals to 1 to this, that will go to 0. So it's only this that will matter. So you will have 6 times 1 squared plus 5 times 1 minus 2 on the left hand side. This will go to 0. This will go to 0, so it's just this one. So it's b times 1, 2 times 1 plus 1. So this one is 2 plus 1, which is 3b, and this one is going to be 6 plus 5, which is 11, minus 2, which is 9. b is equal to 3. So I've got 3 here. Now the second value that I'm going to consider is minus a half. So if I put minus 0.5 or minus a half, I'll use the calculator to evaluate this. Don't risk it. I would always use it because it's so easy to make a mistake when you put a fraction in and with a minus. So I would put it minus 0.5 equals, and then I will do 6 times ans squared plus 5 times 6, which is answer minus 2, and that will give me minus 3 on that side. Okay, and then you can do it for the next one as well if you want to, but we're going to sub minus a half into this part. That will go to 0. Into this part, that will go to 0. So this one will be 0 plus 0. Last one is only the one that matters. So it's going to be c times minus 0.5 times minus 0.5 minus 1. So that's going to be positive. You can do it on the calculator. 3/4. Okay, 1.5 times a half is 0.75. Okay, so that means that we are going to have c is equal to minus 4 when you divide by 0.75. And lastly, we're going to make the third term disappear, so it's x equals 0. So that will be easier. Put 0 into this, you're going to get minus 2. And put 0 into this with b and with c, that will go to 0. So you're just left with this one. So it's a, and you've got 0 minus 1, and then 2 times 0 plus 1. So that will give you minus a on this side. A is equal to 2. So the final answer, let's just pop it on here. That's going to give me 2 over x minus, no, b was positive, plus 3 over x minus 1, and minus c is 4. So put minus here and put 4 in the numerator. 2x plus 1. Let's just double check whether I'm right here. So it's 2 over x. That's correct. So exercise 1D before we move on to the next example.